Problem 3-104. Solve the equations and inequalities below. Check your solutions if possible. So we have A, B, C, and D, and each of these is a different type of equation or inequality. A, we have the absolute value of 5x plus 8 is greater than or equal to -4. And I'll go ahead and do the algebra behind this problem, but if we think about it from a logical standpoint, there's going to be any value of x should make this statement true. And the reason why, when we take the absolute value of anything, remember absolute value being the distance a number is from 0, so distances are positive numbers, we can't have a negative distance. Well, any value that we get when we simplify 5x plus 8, and then we take the absolute value of it, we'll get a positive value. And all positive values are going to have to be greater than or equal to -4. If we ended up with 0 inside our absolute value, that's still greater than -4. So the only thing here that we need to remember is an absolute value is always going to be greater than or equal to a negative number or a negative value. But we can go ahead there. This is a disjunction. We can kind of go ahead and do the math behind it. This was something that was taught in Algebra 1. We have to think about it as we set it up here because it is a disjunction. We want to take it and we want to say we're looking for the values of 5x plus 8 that are greater than or equal to -4. Or we also want to know the values of 5x plus 8 that would have been less than or equal to +4. When we take these and we solve these, subtract our 8 from each side, we have 5x is greater than or equal to -12. We finish solving it, and we get that x is going to be all the values greater than or equal to -12/5, or -2 and 2/5. Solve our other value here. We're going to subtract our 8 from each side, and we have 5 times our value of x is less than or equal to -4. Go ahead and divide each side by our 5, and we get x is less than or equal to -4/5. And remember, because this is a disjunction, we have to include or between our two expressions there, or our two inequalities. Now here's the reason we end up with the value of x can be any number or any real number here. If we wanted to take these and graph these two inequalities, this disjunction, and remember we're going to be looking at the union of the two inequalities here. So I'll graph each one and then we can look at, I'm going to have 0 would be over here. I'd have -4/5, because -4/5 is greater than -12/5. So I'll put my -12/5 here. If I graph my x is greater than or equal to -12/5, I'd want to have a closed circle to show that it can equal -12/5. If I plug in -12/5 here, I'm going to get, well, we'll talk about that in a second when we get to that point. But greater than or equal to -12/5 means we're talking about going this direction, all the values that are greater than -12/5. Talking about all the values that are less than or equal to -4/5, and I'll do this one in red so we can kind of tell them apart here. Well, -4/5, if I plug that in for x there, that makes it true, so I want to include -4/5, and everything less than -4/5, which should be traveling to the left down the number line. So we're saying here that our solutions include all of these values going this way, or they can include any of these values going this way. if we took these two number lines and we put them right on top of each other, let's see if I can even do that. If I took this and I moved it, what would happen here? I forgot my little circle there. I'll move that down there. Are there any breaks in our number line at all? There aren't. So which means here we just have a solid line that goes on forever to our negative values and goes on forever to our positive values here. So it spans the entire number line, which tells us that our solution there is going to be all real numbers. Any value that you plug in for x will make that true. I encourage you to go ahead and try it there. Plug in any value for x, and it should make that original statement true. Now let's look at b. We have x squared plus x minus 20 equals 0. So, I'm sorry, is less than 0. So we're thinking about all our values of x that are going to give us the value of this expression that is less than 0. So if we think about this, I want you to think about it in this respect. If this was just a function that we were looking at, okay, normally when we're dealing with this function and we graph it, this would be a parabola. When we put in that it equals 0, think about what points we're finding. Think about what points we're finding there when we plug in 0 for y. Okay, that should be our x-intercepts. This would give us our x-intercepts. So when y is 0, when our y value is 0, we're looking at all of the points that we're thinking about are on the x-axis. So our original inequality at the top says x squared plus x minus 20 is less than 0. We want to know on our parabola which points will we have that are going to have our y values that are going to make it so we're less than 0. So when are we less than 0 on the y? Well, when we're underneath the x-axis. So let's find our boundary points first. Let's go ahead and solve this equation first, and then we'll talk about how to figure out the rest of our solution. So look at x squared plus x minus 20 equals 0. Let's find our boundary points here by factoring this first, or finding our roots, we could say. So the quantity of x squared plus x minus 20 equals 0. When we factor that, we're going to get x and x. We should have a plus 5 and a minus 4 equals 0. We solve each of those for x to figure out what value of x would make that equal 0. So we get x equals -5, or x could equal 4. And if I take that and I'm going to draw a little bit bigger coordinate plane here. Sorry if it's not completely straight. I've got 1, 2, 3, 4, 5. We've got 1, 2, 3, 4, 5. So this is -5. This is +5 on our. So we know that when x is -5, and I'm going to go ahead there, we'll make that blue here so we can see it. That's supposed to be blue. There we go. And x is equal to 4, we'd have a point here. Now remember, this is what it would be if we were looking for what made x, or what made our values equal to 0. When we look at our original inequality up here, we're looking for the values that make x squared plus x minus 20 less than 0. I know that negative 5 will make it equal 0. I know that positive 5 will make it equal 0. So I have some areas here that I can kind of test out. Let's look at values that are less than negative 5. Let's look at values between negative 5 and positive 4 here. And let's look at values that are greater than 4 and see which section here is going to make it true. So let's take a value from over here. So let's go with a number that's less than negative 5. Let's go with negative 6. And let's plug it in. So I'm going to say negative 6 squared plus a negative 6 minus 20. And we're seeing if that is going to be less than or equal to 0. Well, negative 6 squared, remember you got to put the parentheses. We have 36 minus 6 minus 20. Is that less than 0? Well, 36 minus 6 is 30. Minus 20 is 10. Is 10 less than 0? I hope you said it wasn't. So that doesn't work. So we know that negative 6 out here, this isn't going to work for us. Let's choose a value inside of here. Well, a real easy one to work with there would be, how about 0? Let's try 0 here. 0 squared. And the reason we choose 0 is because it's very easy to simplify. 0 squared is 0 plus 0 minus 20 gives us negative 20 is less than 0. That works. That works here, which means that we're looking at the values between here that are going to be solutions. And then let's go ahead and just try a value that's greater than 4 just to make sure. So we've got 5 squared plus 5 minus 20. We want to know, is that going to be less than 0? Well, 25 plus 5 is 30. Minus 20 is going to be 10. And we know that 10 is not less than 0, so that does not work. So our values that we're looking at here that would make this true would be all the values between negative 5 and positive 4, but not including negative 5 and positive 4. So if we were going to graph that on just a number line, that's what we're looking at there. If we were going to write that out, our solution would be written as x is going to be greater than negative 5, so x is greater than negative 5, and x is less than 4. All right, moving on here. Problem C. We have 2x squared minus 6x equals negative 5. So we're going to take this and solve it for x. Now some of us might be thinking, hey, let's go ahead and factor the 2x out because there's a common factor here. But we don't want to do that when it equals negative 5. We got to set it equal to 0 first. So we're going to have 2x squared minus 6x. And what I'm going to do is I'm going to go ahead and add 5 to each side. So I'm going to end up with plus 5 equals 0. So we have a quadratic. First thing we check here now, does it factor? And because I've already worked this out, I'm going to tell you that this problem does not factor. This will not factor. So the next thing we need to try here, or if you maybe chose to do this first, is the quadratic formula. So we're looking at, say, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So here we go. We know that A is 2, B is equal to negative 6, and C is equal to 5. Let's take these values and plug them in. So x equals, we're going to say the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times 2 times 5 all over 2 times 2. And let's get to work simplifying. The opposite of negative 6 would be 6. So we have 6 plus or minus. Let's simplify the inside of our radical here. Negative 6 squared, and make sure if you're using a calculator that you put parentheses around that. But you should end up with 36 minus 4 times 2 times 5. Well, 4 times 2 is 8. 8 times 5 is 40. All over 4. And this is the part where we end up with a little bit of a problem. If you think about 36 minus 40, we're going to have 6 plus or minus the square root of negative 4 all over 4. Well, the reason this creates a problem is we can't take the square root of negative 4. But what does this mean for us? Well, we're not going to be able to simplify this down and get a real number solution. So what we end up with is no solutions, because we can't take the square root of that negative to get a real number solution. Now, what does this look like on a calculator? Well, let's take this and graph this function here. 2x squared minus 6x plus 5. So let's get out our TI Smart View here. Let's go down. Actually, let me just clear out the function we have there. And I'm going to go ahead and type in 2x squared minus 6x plus 5. And remember, by setting this equal to 0, we're trying to figure out our roots, or where our parabola crosses the x-axis. But down here, if we say there's no solutions, that should mean that it does not cross the x-axis. So I'm going to go ahead and just zoom 6. I'm in my standard window. And when it graphs it here, we're going to see it gets down here really, really close. In fact, let's actually zoom in so we can see there that our parabola comes down and it gets close to our x-axis, but it does not touch at all, which is why we have no solutions or roots, because we have no values, or our y is 0. Our parabola does not make it down that far there. So there are no solutions or roots there. So that is the reason for that. We see that in when we do the quadratic formula here, because we end up with a negative under the radical. If you have more questions about this, make sure you ask your teacher. I only have so many minutes on this video, and I'm sure it's probably getting long. All right, D. Let's go ahead and solve this. We have 5/9 minus x thirds equals 4/9. Let's go ahead here and make this a little bit easier by getting rid of our fractions. We have no variables in our denominator here, so I can do the same thing here to both sides of my equation to make it easier. And I'm going to go ahead and multiply both sides times 9. I'm not worried about getting a common denominator. I'm getting rid of my fractions because it's an equation. 9 times 5 is 45, divided by 9 is 5 again. We have 5 minus 9 times x is 9x, divided by 3 is 3x. 9 times 4 is 36, divided by 9 is back to 4. So we have 5 minus 3x equals 4. Let's go ahead and subtract our 5 from each side. I have negative 3x is equal to 4 minus 5 would be negative 1. Divide each side by -3, and we're going to get that x equals 1/3. To check our answer, we can take it, we can plug it back in. When you do that there, we should have 5/9 minus 1/3 divided by 3 equals 4/9. Well, let's go ahead here. In order to be able to subtract our fractions, we know we have to have a common denominator. That's what you've been working on in class. So I need to multiply this middle fraction by a value of 1, or a form of 1 that would help us get rid of the thirds and turn them into ninths. If we take that and we multiply it by 3/3, remember that's the same thing as 1. 3 times 3 is going to give us 9. And 3 times 1/3 gives us 1. So what we're really looking at is 5/9 minus 1/9. We get 4/9, which we know is a true statement there. All right, sorry this one got long, but you have the ability to fast forward if you need to. If you have questions, make sure you ask your teacher. I am wiped out.